So today's class we are going to study about the application of the adaptive filter. So one of the application of adaptive filter is removing the 60 Hz power line interference in the ECG signal. So if you see, this is the block diagram which illustrates the process. So first, the primary signal is signal plus noise. So you can able to see the ECG signal. It is added with the 60 Hz, 50 Hz noise interferences here. So the signal plus noise is considered as the primary signal. Then the noise, the 50 Hz noise interference is considered as a noisy signal which is sent to an ADC, that is analog to digital converter, then sent as an input to this adapter filter. Now the primary signal, the signal plus noise, it is given to an amplifier. So it is amplified and given to the analog to digital converter. So it will produce the digital signal as an output. Now we'll getting the two signals. One is after sending to the adaptive filter. So the adaptive filter nature is it adjusts the filter parameters according to the input signal. So this adaptive filter produces the output called Y of k, which is the actual output is produced by the filter. Then D of k is nothing but the desired signal. So this desired signal and actual output is given as an input to this comparator. So this comparator, it will compare these two signals and produce the error signal. So if the error is 0, then we can say that we can able to extract the noise-free ECG signal from this. If the error is maximum, so in that case, the error signal is fed back to the adaptive filter. Now the adaptive filter will adjust the weights according to the error signal, input signal, then it produces the output. So this process is a cyclic process until we are getting the error value as 0, and when the error is 0, then we can able to extract the signal. So the signal which we have extract is a noise free signal. You can able to see the ECG signal without any noise. So the power line 60 50 Hz power line interference is easily eliminated by using this adaptive filter. So this is the one of the applications of the adaptive filter. The next application is we are going to enhance the fetal heartbeat compared to the mother's heartbeats. That means we are going to cancel the mother's heartbeat from the fetal heartbeat. So here in this case you can able to see there are two signals. One is primary signal, another one is reference signal. So the primary signal is you can able to see the baby's heartbeats plus the mother heartbeat is given as a primary signal given to the analog to digital converter. And the reference signal is the mother's heartbeat, so which we have to eliminate it. So that is given as A to D converter. So this will produce the digitized output here and which is fed to the adaptive filter. Now this adaptive filter will adjust the filter parameter according to this particular mother's heartbeat signal and produce the filtered signal. And when you see this primary signal, the baby's heartbeat plus mother's heartbeat is fed back to the analog to digital converter, which converts the digital output. So, which is our output, we call it as D of k, which is the desired signal. Now, this comparator, it compares the desired signal with the filtered signal and it produces the error signal. So, here when the error is 0, then we can able to extract only the baby's heartbeat. We can eliminate completely the mother's heartbeat. Suppose if the error is maximum, in that case, the error signal is fed back to the adaptive filter. This adaptive filter again it will adjust the weights according to the signal input signal and produces the filter output. So in this way, the process is cyclically it is repeated until you are getting only the baby's heartbeat and eliminating the mother's heartbeat. So this process occurs in this adaptive filter application. So the next one is background noise suppression. So if you see the car or a helicopter, some background engine noise will be there. So that is often uncorrelated with the reference signal. So we have to eliminate the background noise. So if you see in the car or a helicopter, the pilot will speak. So its speech should be heard to the uh, um, its speech should be heard to the passengers who are sitting there. So in the primary microphones, he speaks. So during when he speaks, definitely his speech signal plus the noisy signal, background noise signals get overlap. So that will be amplified and sent to the analog to digital converter, which will produce the output as a digitized signal called D of K. Now the noisy signal, background noise, which is produced in this microphone, it is sent as a reference signal to analog to digital converter. It is again converted into digital signal and sent to this adaptive filter. So this adaptive filter, it adjusts the weights according to the input signal and it produces the filter output. Now this comparator, it will compare the actual output with the filter output, desired output with the filter output and produces the error signal. So here the signal of interest is only the pilot speech. The background noises should be completely eliminated. So when the error is maximum, in that case the error signal is again fed back to the adaptive filter. Again the adaptive filter will adjust the weights according to the input signal and the adaptive filter functions by an LMS algorithm. So which we call it as new weights equal to old weight plus new learning rate parameter into xk, which is an input signal, into the error signal. So that is an LMS algorithm. Based on the LMS algorithm, the adaptive filter, it will produces the filtered output. So till we are getting only the speech signal, this process is repeated and we are going to suppress the background noise in the case of adaptive filter. Thank you.